Hello class, this is a video tutorial on exponential equations revisited. So prior to knowing logarithms, we solved exponential equations by index laws and observation. So you can pause the video and take a look here because these are the exact same ones that we've done before. So let me demonstrate to you what we mean. In this case, we could simplify 81 to 9 squared. And we can simplify 9 to 3 squared, and by index laws, the 2's become 4 by multiplication. Then we made a leap from here to the last step. Only through observation we can see that, oh, those two must be the same, therefore x is equal to 4. Same goes for this one. We made the bases the same. So 25 becomes 5 squared. And by observation, we can see that these two powers must be the same. So that we could say just, oh, therefore 2x equals 2, and this example as well. However, now by utilizing logarithms and relevant log laws, we can solve exponential equations far more easily. Also, we can solve more difficult exponential equations in future. So let's solve the following equations. Let's actually move this down. We're going to need some more space. So for this, we can actually do this in one of two ways. The first way is just going straight into the definition of a logarithm. This can be converted by definition of the logarithm. Log base 3 of 81 is equal to x. And now we can solve this by use of change of base. So ln of 81 over ln of 3. Going straight into a calculator, this becomes ln of 81 over ln of 3. X is equal to 4. Another way that we can do this is by use of balancing the equation. Taking logarithms is another thing that we can do. So for example, if we had 2x plus 1 equals 5, recall that we can balance the equation by, if we take 1 from this side, we take 1 from this side as well. A new operation that we can do is take the logarithm of both sides. So I can take the logarithm of the left and the logarithm of the right. Now the logarithms that we take have to be the same base. So in this case, I'm taking ln of both sides. Now take notice, ln of this to the power of 2x minus 1. This power, because of the previous logarithm laws that we saw, powers become the coefficients. So this becomes 2x minus 1 ln 5 equals ln of 25. We're going to divide both sides by ln of 5. This will leave us with, so these two cancel, leaving us with 2x minus 1 equals ln of 25 over ln of 5. Let's evaluate that. Ln 25, ln 5. That's equal to 2. So 2x minus 1 equals 2. And now we can solve this by regular use of algebra. So 2x equals 3, x equals 3 over 2. Same case for this one. I'm going to take the logarithm of both sides. This becomes ln of e to the power of 3.4x equals, taking the logarithm of the right side as well, ln of 100. That 3.4x becomes the coefficient, 3.4x times ln of e equals ln of 100. Dividing both sides by this number here, so dividing by ln of e on both sides, this becomes 3.4x equals ln of 100 over ln of e. To solve for x, I'm going to divide by 3.4 on both sides. This will give me, this cancels, so x by itself, ln of 100 over 3.4 ln of e. Ln of e cancels because that's log base e times e, that cancels, leaving me with ln of 100 over 3.4 is equal to x, and that we can approximate by inputting it into our calculator. Ln of 100 over 3.4, and x is approximately 1.35 to 2 decimal places. Let's do the last two examples here. In this case, we want to solve for t in this case. Now take a look. This coefficient we can remove first. We're going to divide both sides by 50. Let's do this in a different color, so divide both by 50, leaving me with e by itself, 0.15t. 2000 divided by 50, well, 20 divided by 5 is 4. Cancel those. That's 40. Now I can take the logarithm of both sides, ln of the left, ln on the right. This power becomes the coefficient, so this becomes ln 40 equals 0.15t ln of e, so that's timesing. This will cancel because log base e of e, so just to show you here, if I take ln of e equal to 1, so that cancels, leaving me with ln 40 equals 0.15t. Solving for t, we can divide by both sides by 0.15, leaving me with t by itself. So t is equal to ln of 40 divided by 0.15. I can leave this in exact form like this, or we can approximate this to become ln of 40 over 0.15. That is approximately 25.59, 2 decimal places. One last question here. Oops. In this case, it's a lot more difficult. Now, one last note that you should know: before you take the logarithm of both sides, you should have the side that you want the coefficient to be by itself. So for example, if I take the logarithm of this expression right now, it will become ln of everything on the left. So it'll become this. So the logarithm is of everything on the left. So we can't take the logarithm straight away. So what we have to do is isolate e, because that is the one that has the power. So for example, we'll get rid of the -1 first. So 2e to the power of half x plus 1. We can get rid of that by adding 1 to the right hand side. So 66.23. We can eliminate the 2 by dividing by 2. So e half x plus 1 equals, let's use a calculator for this, 66.23 divided by 2 is 33.115. So 33. And now that e, or the base power is now by itself, now we can take the logarithm of both sides. So ln of the left and ln on the right. This power becomes the coefficient, so half x plus 1 ln of e equals ln of 33.115. ln of e cancels, leaving us with half x plus 1 equals the right hand side. We'll subtract 1 first, so half x equals, now be very careful, because when you subtract 1, you're not subtracting 1 from this, you are subtracting 1 from everything. So ln of 33.115 minus 1. We'll multiply everything by 2. X is equal to 2 ln 3.115 minus 2. We'll input this into a calculator to get an approximation. That will leave us with 2 ln 3.115 minus 2. Oh, minus 2. That's 4.99999, which is approximately 5. So I hope that gave you an insight into utilizing logarithms to solve exponential equations. Hope to see you in the next video. Best of luck.